All right, page 88. Now we're going to put this to the test. Predicting the range of an angled shot using or based on the known muzzle velocity. So we're going to shoot a projectile at an angle, predict where it's going to land. And this is going to have a lot of moving parts to it. But again, we have to keep in mind what Galileo says. Galileo says, limit the scope of inquiry, the pizza principle, all right? So we're going to bust this up into individual pieces and parts. The ball bearing is going to go up, and then it's going to come down. So that will be event 1, and this will be event 2. Now, in the overarching theory, number 1, the proposition is that Sx is going to equal Vx times the time total. And the time total is the time of event 1 plus the time of event 2. So we need to figure out how long it's going to take to get to apogee, its highest point, how long it's going to take to come back down. That will be our total amount of time. We need to figure out what velocity along the x-axis is. All right. Well, this is where the trig comes in. So Vx, we're going to use a little bit of trig to figure out Vx. Remember, hypotenuse, opposite, adjacent. Okay, adjacent equals the sine of the angle times the hypotenuse. The angle is 37 degrees. I picked 37 degrees because it's a nice odd number. So I'm going to go cosine 37 times my muzzle velocity, I got 3.949. And while I'm at it, I'm going to calculate my initial velocity going up, my Vy. And that's opposite. Remember, in trig, opposite equals the sine of the angle times the hypotenuse. So I'm going to go sine 37 degrees. I got 0.602 times my muzzle velocity, 4.945. I got 2.976. All right. Okay. So, I got Vx 3.949. And now I need T1 plus T2. So how do I figure out T1? Well, T1 is going to equal Vf minus Vi over A, which in this case is going to be 0 minus 2.976. And my acceleration of gravity is going to be negative because it's opposing that vector of velocity, negative 9.8. .976 divided by 9.8. I got 0.304. So T1, 0.304 seconds. All right. Now I have to figure out T2. Well, how would I do that? Well, if I can figure the total height, then I can figure out how long it's going to take to come back down. So that means I got to figure out how high it's going to go. That's SY1. I think that's how I put it in our, yeah. And I'm going to add that to the height above the floor, which is SY2. So how do I do SY1? Well, SY1 is going to equal final velocity squared minus initial velocity squared over 2a. Zero squared minus 2.976 squared over 2 times negative 9.8 2.976 squared equals negative 8.857 over negative 19.6 0.452. All right. Now I'm going to do some remeasuring over here. I'm going to change the angle of my launcher to 37 degrees, which raises the muzzle, so I'm going to have to remeasure that. So now, that muzzle height is 1 meter and 9 centimeters, 1.09 meters. Now we'll add the two. I get 15.42. I'm sorry, 1.542. 1.542. All right, so that's my total height, supposedly. So my time coming down, T2, is going to equal square root of SY total over 0.5a, which is going to be square root of 1.542 over 0.5 times 9.8 which gives me 3.15. 0.315. Yeah, 0.315. All right, so square root of 0.315, 0.561 now we do a sanity check. T2.561. And we would expect it to be a little bit longer than T1, and it is. So yeah, at least it makes sense at first blush. So now we have T1 and T2. T1.304 plus T2.561 0.865. All right, so now we have all the pieces and parts. We have Vx, 3.949. We have T1, T2, we have T total. So we'll bring it down here. Sx equals Vx times T total, which is 3.949 times 0.865 I got 3.416. .416 meters. That's where it should land. So we're going to pause here and then we're going to get set up for the test shot.